Okay, this is a lesson on factoring. This is our very first lesson on factoring polynomials, and the first kind of lesson we do within this unit is to learn to factor out the greatest common factor and factoring by grouping. So let's lead to recalling what a greatest common factor is of two or more numbers. But let's just start with what a factor of a number is, and a factor of a number is a whole number that divides evenly into another given whole number. And remember, divides evenly means it divides without remainder, divides into without remainder. So a factor of a number is a whole number that divides evenly into a given whole number. So for example, 4 is a factor of 12. 4 is a factor of 12 because 4 divides evenly into 12. 12 divided by 4 is 3. There's no remainder. So let's talk about a prime factorization of numbers. That's breaking a number down into the product of its prime factors. So let's take a number such as, let's go with 56. Now 56, you'll recall, is 8 times 7, and 8 can be expressed as 2 times 2 times 2 times 7. And when we work with prime factorizations, we use the exponent form of prime factorization. So anytime you have a multiple, have a prime factor that is used more than once, you just express it as a power. So we want to use exponent form prime factorization. So we would call this 2 cubed times 7. So, and remember, prime numbers are numbers that their only factors are 1 in them and itself. So 2 is a prime number, 7 is a prime number, 8 is not a prime number. So again, this is all material from previous years, so I'm moving pretty fast here. So now let's talk about greatest common factors. So let's say I was talking about number 56 and 72. And I want to know what the greatest common factor is. And remember, the greatest common factor of two or more numbers is the largest whole number that divides evenly into two or more given whole numbers. So when we say we're looking for the greatest common factor of 56 and 72, we want to find the largest whole number that divides evenly into both 56 and 72. So the way we do this is we do a prime factorization of both numbers in exponent form. So 56, I did that up above, so we already know that's 2 cubed times 7. And 72, well, that's 8 times 9. So that's 2 cubed times 9 is 3 squared. So I'm going to So then what I'm going to do is I'm going to stack these two numbers. I'm going to say 56 equals 2 cubed times 7, and 72 is equal to 2 cubed times 3 squared. Well, since 7 is a factor of 56 but not 72, that can't be a common factor, and definitely not the greatest common factor. And 3 squared is 3 and 3 squared, so that's 3 and 9 are factors of 72, but neither are factors of 56, so those can be ruled out. Then I have 2 cubed and 2 cubed, that's 8. Well, that has both of those, 8 has a factor of 4 and a factor of 2. Those are both common factors of 56 and 72, but the greatest common factor of 52 and 72 is 2 cubed itself. So you want to pick the since 2 cubed is part of both numbers, that's the greatest common factor. If we had, let's say we had a 2 cubed and a 2 squared, then we'd pick 2 squared because 8 would be a factor of the larger number, but not the other number. So we're going to say our greatest common factor here is 2 cubed, or 8. So 8's the largest number, largest factor of both numbers that divides evenly into both numbers. So now let's move on to actually doing some algebra. And we have to apply the concepts for GCF with monomials that have variables involved, and the principles stay the same. So if I want to find the GCF of of 5x squared and 10x, well, let's do a prime factorization of both, and the way I do that, if there's variables involved, I can say 5x squared is equal to 5 times x squared. Now the prime factorization of 10x is two times 5 times x. Well, 2 is not a common factor of both numbers, so that can be excluded, but 5 is a common factor. And when you have x and x squared, x is the common factor. X squared is not common to both monomials. It's only but the x is a factor of x squared, so x is the common factor to both numbers. So we're going to say our GCF here is equal to, we take the 5 and we take the x, and that's our greatest common factor of 5x squared and 10x. Now, when I have 8, looking over here, I have 8y cubed and 12y squared x. So let's do prime factorizations for both. So, okay, so the prime factorization of 8y cubed is 2 cubed times y cubed. And the prime factorization of 12y squared x is equal to 2 squared times 3 times y squared times x. So we can first look at, to find our GCF, we can first look at, well, we've got 2 cubed and 2 squared, so that's 8 and 4. Now 8 is a factor of 8, but it's not a factor of 12. But 4 is a part of 2 cubed, and there's 4 in 12. So 4, or 2 squared, is actually what I'm going to take from that 2 squared and that 2 cubed, because 4 divides evenly into both numbers. 3 is, you'll notice this 3 here, that's a factor of 12, but not 8, so I don't need to include that. Now I have y squared and y cubed. Y squared is a part of y cubed, but y cubed is not a factor of this 12y squared x, but y squared is a factor of both numbers, or both monomials. So I'm going to take the y squared, and x is a factor of the 12y squared x, but not of the 8y cubed, so I don't include that. So I'm left with a GCF of 4y squared. Now down below here I have three monomials, and I'm going to find the greatest common factor of the three monomials. So I have 6x squared y squared. So the prime factorization of that monomial will be 2 times 3 times x squared times y squared. And I have 12xyz. Well, 12 is 2 squared times 3. And then I have times x times y times z, and then I have 18xy squared z cubed, and that's going to be 2 times 3 squared times x times y squared times z cubed. Alright, so remember, all common factors here are going to have to be common to both, to all three, so I've got to bear that in mind. So my greatest common factor here will be equal, okay, so let's look at when I have 2, 2 squared, and 2, well 2 is the greatest common factor of those. Because 4 is a factor of 12, but not of 6 and 18. Next I need to look at the 3's. I have 3, 3, and 3 squared. Well, 3 is the common factor. 3 is common to all three coefficients, the 6, the 12, the 18. So that's times 3, and then I'm going to look at I have x squared, x, and x, just like I did with the numbers. I'm just going to take the x. X is the common factor to all three monomials. Then I have y squared, y, and y squared. It's going to be y. And then I have z and z cubed, but there's no z's in the first monomial, so I've got to stop there since z or z cubed does not go into 6x squared y squared. So my GCF will equal 6xy. Okay, so now that we have our GCF skills reinforced, let's start doing some factoring. So our instructions on these are to factor the polynomials by factoring out the greatest common factor. And really, one thing I'd want to tell you here that's going to be going on is that really we're doing the reverse of the distributive property here. Let me get that looking a little prettier. So, for example, so what I'm doing here is I want to take the common factor, I want to look at 4x and 8, and I want to say what's the greatest common factor of those? Well, it's 4. So I'm going to factor out a 4, and I'm going to say, well, if I was to distribute a 4, what would I distribute 4 to here that would equal 4x minus 8? Well, now I'm going to have that minus sign in the middle, so 4 times what equals 4x? Well, that's just x, and 4 times what equals 8 is 2. So now I've accomplished what I set out to, which is to factor from these two terms in this binomial the greatest common factor, and I leave behind the factors that remained after I factored out the greatest common factor. So you'll know you're right here is if I say 4 times x, well, that equals 4x, and 4 times 2 equals 8 with that subtraction sign between them. So in this next one I'm looking at 6x squared and 9x. My greatest common factor, hopefully you realize, well, the greatest common factor of 6 and 9 is 3. The greatest common factor of x and x squared is x. So I'm going to factor out a 3x. Now, what remains when I factor that out is what I would multiply 3x by to get 6x squared. Well, that would be 2x. Minus what I would multiply 3x by to get 9x, and that's 3. So that's the result of factoring out the greatest common factor from that binomial. A little more complicated down here. I've got 16a to the 4th b squared minus 24a squared b cubed. I'm not taking the time to show the process for finding the greatest common factor. Hopefully you can start to eyeball this, but the greatest common factor of 16 and 24 is 8. The greatest common factor of a to the fourth and a squared is a squared. The greatest common factor of b squared and b cubed is b squared. And then I'm going to multiply by the two factors that get what I started with. So 8 times what equals 16? 2. A squared times what equals a to the fourth? A squared. And I've got b squared times what equals b squared? 1, so I don't have to put anything. Then I have 8 times what equals 24? 3. A squared times what equals a squared? 1. Don't need to put anything. B squared times what equals b cubed? B. So that's the result of that one. The only thing that differs in this one is it's a trinomial, so I've got to find the common factor to all three terms. In this case, it's just 2. So I pull out the 2. 2 times what equals 2x? X. Minus 2 times what equals 4y? 2y. Plus 2 times what equals 8z? 4z. Alright. So on this next one, let me actually clean this up. So I have 3x squared minus 6y equals 9x squared y, or 3x squared minus 6xy plus 9xy squared. My greatest common factor here is going to be so if I look at the 3, 6, and 9, my greatest common factor is 3. If I look at the x squared, x, and x, my greatest common factor is x. There's not y's in each term, so 3x is going to be my greatest common factor. Now, what remains behind are the factors that I would multiply by to get what I started with. 3x times what equals 3x squared? That's times x. 3x times what equals 6xy? Well, that would be 2y. And then 3x times what equals 9xy squared? Well, that would be 3y squared.